Hello everyone, I'm Ghaith, a master's student at University of Alberta and part of Reservoir Geomechanics Research Group. I'm glad today to present my project titled Revisiting the UTF as a SAGD project, Reservoir Geomechanical History Matching, including underlying tunnel response to SAGD. So to start warming up with the background. The underground test facility UTF Phase A was constructed in 1987 as a pilot test of SAGD process. The project consists of two 4-meter diameter shafts to a depth of 223 meters, which is below the oil sands, and a 1.5 kilometer rectangular tunnel driven into the limestone, which is the formation, at 185 meters. Phase A has 3 well bears drilled horizontally upwards into the reservoir, and those well bears are 160 meters long, with 60 meter in a horizontal section in the reservoir. Also, it has 28 observation wells, and the final achieved recovery of Phase A is about 53%, which surpassed the expectations. Here we have two figures. The first figure shows the general layout of the UTF with phase A here, along with all other phases of UTF. And the second figure shows the schematic representation of phase A. So now for the next section, which is the purpose, the motivation of the project. So first of all, going back to the question of why phase A specifically. The reason behind that is that phase A has an extensive monitoring program data, and the small size and shallow reservoir that it has will clearly help us in having more accurate results by building a very high resolution model. So also the coupling will show the interaction between reservoir and geomechanical parameters, which is a key factor in performing the history match, as SAGD is a coupled problem. So furthermore, some of the responses in phase A are still questionable and not completely understood, such as the propagation of the steam chamber and the extensometer response. So, the first new contribution of this project will be by building a 3D model, which can allow us for more understanding of the steam chamber propagation. And the second one is to include the underlying tunnel response to SAGD process and try to answer the reaction of the extensometer. So this figure here shows the steam chamber growth at 500 days during phase A. And hence, we can conclude the 3D nature of the steam chamber growth at phase A. And therefore, the importance of this study lies in incorporating the 3D effects and matching the underlying tunnel response to answer whether dilation had any impact on the SAGD behavior during phase A or not. So now moving on to the next section, which is the methodology. So the methodology of this study starts up by collecting the wells data using GeoScout database. So as we can see here, the wells were filtered first by the location, often choosing the boundaries, which is in the in orange color. And those boundaries have chosen to be 500 meters from each side of the reservoir. This is the reservoir, and the boundaries choose to be 500 meters from each side. This size we're choosing because it can ensure that the boundaries uh, do not affect the results during the process. And this is like the simple drawing that shows the shaft in blue, tunnels and phase A reservoir and well bears. As you can see here, the legend of this drawing. But unfortunately, most of the phase A wells are not available and haven't been digitized yet. Hence, the wells were entered manually to be trailed and undergo a raster log digitization, as we can see here. So the methodology of digitization is by uploading the raster log image and then selecting 2 points on the x-axis, as we can see here, to be used as a log scale reference, and then 2 points on the y-axis to be used as a depth scale reference. Then by just picking up the points and follow the path of the profile, the raster log will be converted to digital data, as we can see here. So then the geological model will be constructed based on this workflow that starts with the wells data input, and then create surfaces, then stratigraphic modeling, 3D grid construction, property modeling, and volume calculation. Regarding the reservoir geomechanical coupling work, it will be done by using stars for the flow simulation and Flag 3D for the geomechanical simulation. The flow simulation using stars will provide us with temperature and pressure, which will be transferred to Flag 3D through the RG coupling platform, and then we will get a new permeability and porosity by running the simulation in Flag 3D, the geomechanical simulation in Flag 3D. And those new permeability and porosity will be transferred to stars by the RG coupling platform as well. So this whole process will be performed on specific time steps for the sake of sequential coupling. So going to the next section, which is the results section. So the final number of the wells are 54 in total, in which 50 wells have glass pipes. The figure here shows the layout of the wells, with phase A located inside the green rectangle, which will be served, like this green rectangle will be served as the boundary of higher resolution grid. This image here shows the structural model of this study, which comprised of 3D simple grid construction. So the workflow of the structural model, of this structural model, consists of 3D simple grid, make horizons, make zones, then layering. So as we can see here, the layers are smaller in the oil sands and the underlying formation than in other locations, like the overburden. And this have been done to have a higher resolution in the area of interest and more accurate results. So moving on to the next figure here. So this figure here shows the global grid of the structural model. The legend here is the bulk volume of the grid cells. So the color distribution here represent the volume of each grid cell. As we can see here, the oil sands and formation is smaller. It has smaller grid cells than other area. And then the local grid, we have the local grid of only for the area of interest, which is 1 by 1 grid cells. So moving to the next and last figure we have here. This figure shows the data of the extensometer of station 3. This station was chosen as it was exactly under the well chamber, and we can see the response of the extensometer from here. This response represents a dilation response, as negative sign means extension, and that's graph what we expect to get as a final result of including the formation and analyze its response. Then after analyzing that, we can decide on whether this dilation plays any kind of role on the behavior of SAGD process. So the upcoming work will be on the property modeling, which will allow us to distribute the properties of the reservoir. And after that, we will move to scale up the well logs to move forward to the volume calculation, and that will wrap up the geological model. Then after that, the geological model will be transferred to STARS and SAGD, and the work will start on the reservoir geomechanical simulation. So that concludes the poster presentation. Thank you all for watching and listening, and wish you a great day.